So, Leopold Aschenbrenner is someone who used to work at OpenAI until he was quote unquote fired for leaking internal documents. Now, I do want to state that this video is arguably one of the most important videos because he details the decade ahead for how many of the companies around the world are going to get to AGI, and his insights are like no other. He made this tweet stating that virtually nobody is pricing in what's coming in AI, and he made an entire document about the stages that we will need to take in order to get to AGI and some of the things that you're going to witness in the coming years. I think you should at least watch the first 10 minutes of this video because it is remarkably insightful into some of the things that he is predicting. So there are 7 different sections, and I've read this thing from top to bottom at least 3 times, and I'm going to give you guys the most insightful sections from this entire essay because I do believe that this is a remarkable document that I think everyone needs to pay attention to. So without wasting any more time, let's get into situational awareness, the decade ahead. So he has this introduction here where he talks about how the talk of the town has shifted from 10 billion compute clusters to $100 billion compute clusters to even trillion-dollar clusters, and every 6 months another zero is added to the boardroom plans. The AGI race has begun. We are building machines that can think and reason, and by 2025 to 2026, these machines will outpace college graduates, and by the end of the decade, they will be smarter than you or I, and we will have superintelligence in the true sense of the word. I'm going to say that again. By the end of the decade, okay, we will have superintelligence in the truest sense of the word. Along with the way, national security forces, not seen in half a century, will be unleashed, and before long, the project will be on. These are some very fascinating predictions, but just trust me, once we get into some of the charts and some of the data that he's been analyzing, I think it really does make sense. And this is why this document is called situational awareness. Just read this part before we get into everything. He says, before long, the world will wake up. But right now, there are perhaps a few hundred people, most of them in San Francisco and the AI labs, that actually have situational awareness. Through whatever peculiar forces or fate, I have found myself amongst them. And this is why this document is really important, because information like this, we're really lucky that people could leave a company like OpenAI and then publish a piece of information which gives us the details on how superintelligence is likely to arise and when that system is likely to arise. So this is the section 1, from GPT-4 to AGI, counting the orders of magnitudes. So when you see OOMs, that's what it stands for. So he clearly states here his AGI prediction. AGI by 2027 is strikingly plausible. GPT-2 to GPT-4 took us from preschooler to smart high schooler abilities in just 4 years. And if we trace the trend lines of compute, algorithmic efficiencies, and unhobbling of gains, we should expect another preschooler to high schooler size qualitative jump by 2027. Now this is where we get into our first very important chart, because this shows us exactly where things may go. He says, I make the following claim. It is strikingly plausible that by 2027, models will be able to do the work of an AI researcher / engineer. That doesn't require believing in sci-fi, it just requires in believing in straight lines on a graph. What we can see here is a graph of the base scale up of effective compute, counting GPT-2 all the way up to GPT-4 and looking at the effective compute that we're going to continue to scale up. Now, one thing that is fascinating from here is that I think there is going to be an even steeper curve for this. The reason I state that is because during the period from 2022 to 2023, there was something that I would like to call an awareness, okay? This period right here marks the birth of GPT-3 to GPT-4. And this put a real giant spectacle on the AI era. GPT-3 and GPT-4 weren't just research products. I mean, GPT-3 was, but GPT-4 and ChatGPT 3.5 were actual products that were available for the public. And since then, we've seen an explosion in terms of how many people are now intrigued by AI and how many different companies are now piling billions of dollars and billions of resources into the technology, into the compute clusters, just so that they can capture all of the economic value that's going to be happening during this area, which is why I do believe that it wouldn't be surprising if during the period from 2024 to 2028, we do have a lot more growth than we've had in this period, which means that having an automated AI research engineer by 2027 to 2028 is not something that is far, far off. Because if we're just looking at the straight lines and the effective compute, then this is definitely where we could get to. And the implications of this are quite stark, because if we can have an automated AI/research engineer, that means that it wouldn't take that long to get to superintelligence after that. Because if we can automate AI research, then all bets are off. We're able to effectively, recursively self-improve, but just without that crazy loop that makes superintelligence explode. Now, here's where he states one of the things that I think is really, really important to understand. I stated this in a video before this document was released, but it's glad to see that someone else is ushering one of the same concerns that I originally thought of. He stated that the next generation of models has been in the oven, leading some to proclaim that stagnation and that deep learning is hitting a wall. But by counting the orders of magnitude, we get a peek at what we should actually expect. In a video around 3 weeks ago, I clearly stated that look, things are slowing down externally, but things are not slowing down internally at all. Just because some of the top AI labs may not have presented their most recent research, that doesn't mean that breakthroughs aren't being made every single month. He states here that while the inference is simple, the implication is striking. Another jump like that very well could take us to AGI, to models as smart as PhDs or experts that can work beside us as a co-worker. Perhaps most importantly, if these AI systems could automate AI research itself, that would set intense feedback loops. And that's of course where we get AI researchers to make breakthroughs in AI research, then we apply those breakthroughs to the AI systems, they become smarter, and then the loop continues from there. Basically, recursive self-improvement, but on a slower scale. And here he clearly states, even now, barely anyone is pricing this in, but the situational awareness on AI isn't actually that hard. Once you step back and look at the trends, if you keep being surprised by AI capabilities, just start counting the orders of magnitudes. So here's where we talk about the last 4 years. So you can see he speaks about GPT-2 to GPT-4. GPT-2 was essentially like a preschooler, while it can string together a few plausible sentences. And these are the GPT-2 examples people found very impressive at the time. But yet, it could barely count to 5 without getting tripped up. Then of course, we had GPT-3, which was in 2020, and this was as smart as an elementary schooler. And this was something that once again impressed people quite a lot. Then of course, this is where we get to GPT-4 in 2023, and this is where we get a smart high schooler. While it can write some pretty sophisticated code and iteratively debug, it can write intelligently and sophisticatedly about complicated subjects, it can reason through difficult high school competition math, and it's beating the vast majority of high schoolers on whatever tests we give it. And remember, there was the Sparks of AGI paper which showed some capabilities that showed us that we weren't too far away from AGI, and that this GPT-4 level system were the first initial sparks of artificial general intelligence. The thing is, here he clearly states, and I'm glad he's stating this because a lot of people don't realize this, that the limitation comes down to obvious ways that models are still hobbled. And basically he's talking about the way that models are used and the current frameworks that they have. The raw intelligence behind the model, the raw cognitive capabilities of these models, if you even want to call it that, as artificially constrained. And basically, in the future, if you calculate the fact that these are going to be unconstrained in the future, it's going to be very fascinating on how that raw intelligence applies across different applications. And one of the clear things that I think that most people aren't realizing is that we're running out of benchmarks. As an anecdote, my friends Dan and Colin made a benchmark called the MMLU a few years ago in 2020. They hoped to finally make a benchmark that would stand the test of time, equivalent to all the hardest exams we give high school and college students. Just 3 years later, models like GPT-4 and Gemini get around 90%. And then of course, GPT-4 mostly cracks all the standard high school and college aptitude tests. And you can see here the test scores of AI systems on various capabilities relative to human performance. You can see that in the recent years, there have been a stark stark level of increases here. It's absolutely crazy with as to how many different areas that AI is increasing in terms of the capabilities. It's really, really fascinating to see and also potentially quite concerning. Now, one of the things that most people did actually miss about going from GPT-4 to AGI was a benchmark that actually did shock me. So there is essentially this benchmark called the math benchmark, a set of difficult mathematical problems from a high school math competitions. And when the benchmark was released in 2021, GPT-3 only got 5%. And basically, the crazy thing about this was that researchers predicted at that time, stating to have more traction on mathematical problem solving, we will likely need new algorithmic advancements from the broader research community, and we're going to need fundamental new breakthroughs to solve maths, or as they thought, they predicted minimal progress over the coming years. But by mid 2022, we got to 50% accuracy, and basically now, with the recent Math Gemini 1.5 Pro, we know that this is now at 90%, which is absolutely incredible. And here's something that you can clearly screenshot and share to your friends or colleagues or whatever it is, whatever kind of community that you might be in. But you can see that the performance on the Commons exams percentile compared to human test takers, we can see that GPT-4 ranks above 90% for pretty much all of them except calculus and chemistry, which is a remarkable feat when we went from GPT-3 to GPT-4 in such a short amount of time. This is a true jump in capabilities that many people just simply wouldn't have expected. Now here's where we start to get to some of the predictions that we can really start to make based on the nature of deep learning. So essentially, the magic of deep learning is that it just works, and the trend lines have been astonishingly consistent despite the naysayers at every turn. We can see here that this are screenshots from the scaling compute in the OpenAI's Sora technology, and at each level we can see an increase in the quality and consistency. The base compute results in a pretty terrible image/video. 4 times compute results in something that is pretty coherent and consistent, but 30 times compute is something that is remarkable in terms of the quality, consistency, and the level of video that we do get, which shows us that these trend lines are very consistent. And he says if we can reliably count the orders of magnitude that we're going to be training these models, we can therefore extrapolate the capability improvements. And that's how some people actually saw the GPT-4 level of capabilities coming. And one of the things that he talks about is, of course, things like chain of thought, tools, and scaffolding, and therefore we can unlock significant latent capabilities. Basically, when we have GPT-4, or whatever the base cognitive capabilities are for this architecture, and then we can use that to unlock latent capabilities by adding different steps in front of that system. So for example, when you use GPT-4 with chain of thought reasoning, you significantly improve your ability to answer certain questions in different scenarios. And it's things like that where you can unlock more knowledge from the system by using different ways to interact with it, which means that the raw data behind the system and the raw knowledge is a lot bigger than people think. So this is what you call unhobbling gains. Now, one of the things that's really important, and this is something that doesn't get enough attention, but this is going to make up a lot of the gains that you won't see, and this is the algorithmic efficiencies. So whilst massive investments into compute get all the attention, algorithmic progress is similarly an important driver of progress and is dramatically underrated. To see just how big of a deal algorithmic progress can be, consider the following illustration, this one right here, the drop of the price to attain 50% accuracy on the math benchmark over just 2 years. And for comparison, a computer science PhD student who didn't particularly like math scored 40%. So this is already quite good. And the inference efficiency improved by nearly 3 orders of magnitude, or 1000x in less than 2 years. So what we have here is something that is incredibly more efficient for the same result in just 2 years. That is absolutely incredible. These algorithmic efficiencies are going to drive a lot more gains than you think. And as someone who was looking at Arxiv, which is where a lot of these research papers get published, just trust me, there are like probably 50 to 80 different research papers that get published every single day. And a few of those allow, 10 to 20% gain, 30% gain. And if you calculate the fact that all of these algorithmic efficiencies are going to compound against each other, we're really going to see more cases like this. Here's where you talk about the API cost, and you basically look at how efficient it becomes to run these models. So GPT-4 on release cost the same at GPT-3 when it was released. but since the GPT-4 release a year ago, the prices for GPT-4 level models have fallen 6 times / 4 times for the input / output with the release of GPT-4o. And GPT 3.75 level is basically Gemini 1.5 Flash, and this is 85 times cheaper than what we previously used to have. So we can see here on this graph that if we want to calculate exactly how much progress we're going to be make, we can clearly see that there are two main things here, which is of course the physical compute of scaling, which is going to be things like these data centers and the hardware that we throw at the problems, and then of course the algorithmic progress, which is going to be the efficiencies, where people rewrite these algorithms in crazy ways that just drive efficiencies that we previously didn't know how to solve. And that's why in the future, where we do get an automated AI researcher to do that, this gap is going to widen even more. So this is where we talk about unhobbling. This is of course something that we just spoke about before, but the reason that this is important is because this is where you can get gains from a model in ways that you couldn't previously see before. So imagine if when someone asked you, a math problem, you had to instantly answer with the first thing that came to mind. It seems pretty obvious that you would have a very hard time, except for the simplest problems. But until recently, that's how we had LLM solve math problems. Instead, most of us, when we do math problems, we work the problem step by step and are able to solve much more difficult problems that way. It's basically chain of thought, and that's what we do for LLMs. And despite the excellent raw capabilities, they were much worse at math than they could be because they were hobbled in an obvious way, and it was a small algorithmic tweak that unlocked much greater capabilities. Essentially what he's stating here is that when these even better models get even more unhobbled, we're going to see even more compounded gains overall. And one of the craziest ones that we recently have is, of course, GPT-4 can only solve the software engineering bench 2% correctly, while with Devon's agent scaffolding, it jumps to 14%, which is pretty incredible. And this is something that is very small in terms of its infancies. And it says tools. Imagine if humans weren't allowed to use calculators or computers. We're literally only at the beginning here. ChatGPT can only now use a web browser, run some code, and so on. And of course, this is where we talk about the context length, which is, it's gone from a 2K context length to 32 to literally a 1 million context length. And of course, there's post-training, which is substantially improving the models after you've trained the model, which is making huge gains. We went from 50% to 72% on math and 40% to 50% on the GPQA. And here's where we can see, once again, there is another stack in terms of the growth. So you can see here the raw chatbot from the chatbot to agent. These are things that most people just aren't factoring in when we take a look at the future of AI growth. This is why he says the improvements will be step changes compared to GPT-6 and reinforcement learning with human feedback. By 2027, rather than a chatbot, you're going to have something that looks more like an agent and more like a coworker. Now, one of the craziest things I saw here was that when you take in all of the information that was just stated, this is absolutely incredible because he basically says that by the end of 2027, this is absolutely insane. So we can see the gains made from GPT-2 to GPT-4 by physical compute, algorithmic efficiencies, plus major unhobbling gains from the base model chatbot. In the subsequent 4 years, we're going to see 3 to 6 orders of magnitude of base effective compute scale up, which is the physical compute and algorithmic efficiencies. But basically, he says that with all of this combined, what this should look like. Suppose GPT-4 training took 3 months. In 2027, a leading AI lab will be able to train a GPT-4 level model in a minute. That is an incredible prediction, and I'm wondering if that is going to be true. But then again, you have to think about it. In 3 years, with billions of dollars and that much more compute floating around the industry, I wouldn't be surprised if some of the things that we think right now are sci-fi completely aren't. So here's where we can see everything visualized. We can literally see how we have the base knowledge, then we've got the chatbot framework, then once we have the agentic framework, and of course once we have the more orders of magnitude, we can see that the intelligence by 2027 become an automated AI research engineer. Now that you actually look at all the information from every different single point, it doesn't seem that crazy. Like if you count everything, every single thing into account, this doesn't seem like something that is too far away, especially with the kind of jumps that we've seen before. And maybe, just maybe, with the GPT-5 release and subsequent AI models, we're going to start to see that 2027 and 2026 are going to be incredible time periods. He says we are on course for AGI by 2027 and that these AI systems will basically be able to automate basically all cognitive jobs. Think any job that can be done remotely. That is a crazy, crazy statement. And I think that that is something that you need to, bear in mind. AGI by 2027 is not something that is out of the picture and is something that definitely could happen. So one of the most interesting things as well that I think is really important is that the reason this period is so important is because this is the decisive period. This is the period where the growth occurs and we really get to see what is capable. So he says right here, in essence, we're in a middle of a huge scale up. And this is where we are reaping one-time gains this decade. And progress through the orders of magnitude will be multiples slower thereafter. If this scale up doesn't get us to AGI in the next 5 to 10 years, it might be a long way out. So the reason that this is going to be, so interesting is because it's this decade or bust. So you can see right here that the effective scale up of compute is going to become harder and harder the larger it gets. Because think about it like this. It's like, well, I don't actually have a great example, but we just have to think about how hard it is to invest billions and billions of dollars more to scale up systems even more. So it's like, of course, you can scale up a model from 10 billion to 100 million, but the scale from 100 million to 10 billion is really huge. It takes a lot of investment. You're going to have to data centers, multiple data centers. You're going to have to make them really huge. You're going to have to think about all the cooling. There's a lot of power requirements. And then to get to $1 trillion clusters or even $100 billion or even $500 billion clusters, that's even more incredible. So basically he's stating once we get to the $100 billion level and above, if we aren't at AGI at that level, then it means that realistically, we're going to have to wait for some kind of algorithmic breakthrough or an entirely new architecture, because with the gains that are going to be made by being able to have so much more compute being thrown at the problem, it is very hard for us to make gains based on compute after that. He basically says here that spending $1 million on a model used to be outrageous, but by the end of the decade, we will likely have $100 billion or $1 trillion clusters. And going much higher than that is going to be a lot harder. So it's going to be basically the feasible limit, both in terms of what businesses can actually afford and even just as a fraction of the GDP. And he also states that the large gains that we're getting from CPUs to GPUs will be likely gone by the end of the decade, because we're going to have AI specific chips, and without much further beyond Moore's law, there's not going to be much more gains possible. And the reason this is important, because for those of you who are trying to navigate this entire thing, you're trying to figure out, okay, where AI capability is going to stop, where is the next growth going to be at. It's basically the fact that right now we're scaling up our systems, and once we reach the top of $100 billion to 100 trillion clusters, if we don't have superintelligence or AGI by that limit, then we'll know that maybe we're using the wrong architecture and things are going to have to change significantly. So it's either going to be a long, slow slog, or we're going to get there relatively soon. And by the looks of things, it looks like we're going to get there relatively soon. Now, here's where we talk about AGI to superintelligence, the intelligence explosion. And basically, this is where he talks about how AI progress will not stop at human level. Hundreds of millions of AGIs could automate AI research, compressing a decade of algorithmic progress, which adds 5 orders of magnitudes into 1 year. And we would rapidly go from human level to vastly superhuman AI systems, and the power and the peril of super intelligence would be dramatic. So here's what we have, basically, I think the most important graph, okay? If there's one that you want to screenshot and keep on your phone, I think it's this one, okay? The reason that it is because once you have the GPT-4, GPT-3, GPT-2 timelines mapped out, we can clearly see that this intersection here is at 2023. But of course, as the trends continue, we can see that once we do get to this period right here, this is where things start to get interesting, because this is, of course, the period of automated AI research. And that's why once this does happen, and this is not something that's like a fairy tale, this is something that Sam Altman has said, that's his entire goal. That's what OpenAI are trying to build. They're not really trying to build superintelligence, but they define AGI as a system that can do automated AI research. And once that does occur, and I don't think it's going to take that long, that's when we're going to get that recursive self-improvement loop where superintelligence is not going to take that long after, because if you can deploy 5,000 agents, okay, that are essentially all super intelligent, not super intelligent, but at the level of a standard AI researcher, and we can deploy them on certain problems and keep them running 24/7, that is going to just compress years of AI research into a very short time frame, which is why you can see that the graph during this purple period here, it starts to go up rapidly. And that's why the next decade is so important, because once this area actually happens, once we get to that breakthrough level where, okay, we've automated AI research, then all bets are off, because we know that superintelligence will just be around the corner. And that's when we have the intelligence explosion, because every time an AI researcher manages to make a breakthrough, the AI research breakthrough is then applied to that AI researcher, and then the progress continues again, because now the AI researcher is just that more efficient or even smarter. And here's the crazy thing. This is one of the craziest implications about this entire thing. We don't need to automate everything. Just AI research. I'm going to say that again. We don't need to automate everything. It's just AI research. A common objection to transformative impacts of AGI is that it will be hard for AI to do everything. Look at robotics, for instance. The doubters say that there will be a gnarly problem. Even if AI is cognitively at the level of PhDs, or take automating biology research and design, which might require lots of physical lab work and human experiments. But we don't actually need robotics. We don't need many things for AI to automate AI research. The jobs of AI researchers and engineers at leading labs can be done fully virtually and don't run into real-world bottlenecks the same way that robotics does. And of course, this is going to still be limited by compute, which is addressed later. And basically, that's things whereby, like, the literal hardware issues that you get when you're trying to scale these systems. Like, it's not that hard. Well, I say it's not that hard, but theoretically, it should be easier to read ML literature and come up with new questions and ideas, implement these experiments, test those ideas, interpret the results, and then of course repeat it. And all it takes is for once we get to that level, that's where we have this insane feedback loop. And this is where 2027, we should expect GPU fleets in the tens of millions, training clusters alone approaching 3 magnitudes, larger already putting us at 10 million A100 equivalents. And this is going to be running millions of copies of our automated AI researchers, perhaps 100 million human researcher equivalents running day and night. That is absolutely incredible. And of course, some of the GPUs are going to be, used for training new models. But just think about that, guys. Imagine 100 million human researcher equivalents running 24/7. What kind of breakthroughs are going to be made at that stage? I mean, it's very hard to conceptualize, but it's important to take into account what is truly coming, because like he said, nobody's really pricing this in. And the crazy thing is that they're not going to be working at human speed. They're going to be each working at 100 times human speed not long after we begin being able to automate AI research. So think about it. You're going to have like 100 million more AI researchers, and they're going to be working at 100 times what you are, which is absolutely incredible. They're going to be able to do a year's worth of work in a few days. That is going to be absolutely insane. And you have to remember, like, the current level of breakthroughs that we're getting with just humans is absolutely incredible. So once we're able to automate it, the intelligence explosion is literally going to be unfathomable. Now, this is one of the bottlenecks that most people don't talk about, but of course, it's limited compute. And whilst, yes, now you're probably thinking, wow, this is really incredible. We could really be on the, cliff of something amazing here. But of course, compute is still going to be limited. Then there's also this idea, which I think most people haven't considered, and this includes myself, okay? Ideas could get harder to find and there are diminishing returns, though the intelligence explosion will quickly fizzle. Related to the above objection, even if the automated AI researchers lead to an initial burst of progress, whether rapid progress can be sustained depends on the shape of the diminishing returns curve to algorithmic process. Again, my best read of the empirical evidence is that the exponents shake out in favor of the explosive/accelerating progress. In any case, the sheer size of the one-time boost from 100 to hundreds of millions of AI researchers probably overcomes diminishing returns here for at least a good number of orders of magnitudes of algorithmic progress, even though it can't be indefinitely self-sustaining. Basically, there are a few things that could slow down AI progress, but this is of course something that's far into the future. So here's where he talks about the takeoff for AGI. So he said rather that 2027 is AGI and then we get to superintelligence, which is a very basic look at things, it's probably going to look like this. 2026 to 2027, we get a proto-automated engineer, but it has blind spots in other areas and it's able to speed up work by 1.5 times to 2 times, and already progress begins accelerating. Then of course in 2027 to 2028, we have proto-automated researchers that can automate more than 90% and some remaining human bottlenecks and hiccups in coordinating a giant organization of automated researchers to be worked out, but this already speeds up progress by 3 times. And then, of course, now with AGI and these kind of researchers, we get 10 times the pace of progress in 2029, and that's how we get to superintelligence. And this is thinking about it as a slow method to superintelligence, but the point is that is, ladies and gentlemen, still very, very fast. He talks about how by the end of this decade, the AIs that we're going to have are going to be unimaginably powerful, meaning that even things that you can think of right now, it's going to be pretty hard to conceptualize how great they're going to be. Now, he gives a really interesting, description of how this could actually happen, but it's pretty incredible to think about. Like, he says they'll be able to run a civilization of billions of them, and they're going to be thinking orders of magnitude faster than humans. They'll be able to quickly master any domain, write trillions lines of code, and read every research paper in every scientific field ever written, and write new ones before you've gotten past the abstract of one, learn the parallel experience of every one of its copies, gain billions of human equivalent years of experience with some new innovation in a matter of weeks, and work 100% of the time with peak energy and focus, and won't be slowed down by that one teammate who is lagging, and so on. And of course, we've already seen some of these examples. Things that, like, people talk about in terms of, AI research in the future. This is something that we have seen already before. If we take a look at the famous move 37 in AlphaGo, this is basically where a computer system did a move in a game that was really old, and people were like, why on earth did the AI system do that move? I'm guaranteeing that it just lost. But the move that it pulled, I think the calculation that it would have done that move was pretty crazy. And this system basically thought of a move that no one would have ever thought of, and this move stunned people. It shocked them. Lee Sedol couldn't really figure out what was going on. The human player had no idea what the AI system did, and eventually the human lost that game. And basically, he's stating that superintelligence is going to be like this across many domains. It's going to be able to find exploits in human code too subtle for humans to notice, and it's going to be able to generate code too complicated for any human to understand, even if the model spent decades trying to explain it. We're going to be like high schoolers stuck on Newtonian physics while it's off exploring quantum mechanics. And imagine all of this applied to all domains of science, technology, and the economy. Of course, the error bars here are still extremely large, but just imagine how consequential this would all be. Of course, one of the big things is about solving robotics. Superintelligence is not going to stay cognitive for long. Once we do get, the systems that are at AGI level, factories are going to shift from going to human run to AI directed using human physical labor, soon to be fully being run by swarms of human level robots. And of course, think about it like this. The 2030s to 2040s is going to be absolutely insane because the research and design efforts that human researchers would have done in the next century into years. So think about how we went from the 20th century when we were essentially, going from flying as a mirage. Like people were like, we're never going to be able to fly. Then we had airplanes. Then we had a man on the moon, which was over a couple of years, over tens and, over like 50, 40, 30, 20 years. But in the 2030s, this is going to be happening in a few years, like literally just a short amount of years. We're going to be having different breakthroughs across many different sectors and many different technologies across many different industries. And this is where we can see the doubling time of the global economy in years. From 1903, it's been 15 years. But after superintelligence, what happens? Is it going to be every 3 years? Is it going to be every 5? Is it going to be every year? Is it going to be every 6 months? I mean, how crazy is the growth going to be? Because we've seen that here, like the exponential decreases in time are very, very hard to predict. Here are two of the most important things as well that I think are really, really important. And I know this video is really long, but guys, trust me, this is literally probably the last industrial revolution that's ever going to happen. And it's something that we are being able to witness here with these documents. So there are two things, okay? This is a decisive and overwhelming military advantage. Early cognitive superintelligence might be enough here. perhaps some superhuman hacking scheme can deactivate adversary militaries. In any case, military power and technological progress have been tightly linked historically, and with extraordinarily rapid technological progress will come military revolutions. And essentially, the drone swarms, things that you could do, all the kinds of research and design that you could do to create weapons that you couldn't even think about, it's going to be absolutely incredible. Basically, think about it like this: with superintelligence, compare 21st century militaries with fighter jets and tanks and airstrikes fighting a 19th century brigade of horses and bayonets. That's going to be a war that they simply can't win. The technology that we have, you'd only need an F-22 fighter jet to annihilate the entire 19th century brigade. And the same is going to happen with superintelligence. The research and design efforts are going to create potentially an unstable economy where if we don't get to superintelligence first, and a nation state that is, I guess you could say, on the side of doing whatever they want, they could have technologies that are so far advanced that they could truly have a military advantage over everyone. And this is why I think things are going to change at OpenAI, okay? Whoever controls superintelligence will possibly have enough power to seize control from pre-superintelligence forces. Even without the robots, the small civilization of superintelligence would be able to hack any undefended military election television system and cunningly persuade generals, electorates, and economically outcompete nation states, design new synthetic bioweapons, and then pay a human in Bitcoin to synthetically synthesize it, and so on. And basically what we're going to have here is, I think there's going to be a shift of power, guys. I don't know how the government is going to deal with this, like if they're just going to seize OpenAI's computers or whatever, but whoever literally gets to superintelligence first, I truly believe that all bets are off, because if you have the cognitive abilities of something that is, 10 to 100 times smarter than you, trying to outsmarten it is just, it's just not going to happen whatsoever. So you've effectively lost at that point, which means that you're going to be able to overthrow the US government. So, I mean, it's a pretty interesting statement, but I do think that it is true. And this is where you can see that the moment we get an automated AI researcher, all of these other areas start to take off in remarkable different ways. It's truly incredible. Now, here's where we get to an interesting point, okay? This is where he talks about the security for AGI. And this is really important because after he made this document, OpenAI actually updated their webpage with something as a rebuttal to this part right here. And like I said before, this is why I truly think that at least starting next year, I don't think there are going to be any AI leaks after 2025. And that's because I think the nature of AI is going to change, because they're probably going to realize how serious AI is, and the fact that this is going to be treated like, I guess you could say, a US national secret, in the sense that, like, we just don't get secrets about the Pentagon unless we have a whistleblower who is eventually going to get arrested anyways. And essentially it says the nation's leading AI labs treat security as an afterthought. Currently, they're basically handing the key secrets for AGI to the CCP on a silver platter, securing the AGI secrets and weights. The state actor threat will be an immense effort, and we're not on track. Basically, they're stating that, look, if we're actually going to build superintelligence here, and we're actually going to build something that is really going to change the world, we need to get serious about our security. Right now, there are so many loopholes in our current top AI labs that we could literally have people who are infiltrating these companies, and there's no way to even know what's going on because we don't have any true security protocols. And the problem is that it's not being treated as seriously as it is. It's not like it's the CIA or some secret government organization where they have things going on at the Pentagon or like Area 51 or whatever secret military organization exists that have super clear things in regards to their security. And he's basically stating that right now you don't even need to mount a dramatic espionage operation to steal these secrets. Just go to any San Francisco party or look through office windows. And he's basically stating that right now it's not as serious because people don't realize it. But the thing is, and like I said before, AI labs are developing currently algorithmic secrets, which are the key technical breakthroughs, which are the blueprints, so to speak, for AGI right now. And in particular, it's basically the next paradigm for the next level of systems. And of course, basically what we need to do is we need to protect these algorithmic secrets if we're supposed to maintain this lead, and of course, secure the weights of the models that we need. And they're going to matter more when we get these larger clusters. And he says our failure today will be irreversible soon. In the next 12 to 24 months, we will leak key AGI breakthroughs to the CCP. It will be to the National Securities Establishment the greatest regret before the decade is out. This is, of course, the preservation of the free world against the authoritarian states, and it's on the line. A healthy need will be the necessary buffer that gives us the margin to get AI safety right too. The United States has an advantage in the AGI race, but we're going to give up this lead if we don't get serious about security very soon. And if we don't get this right, we need to ensure that we do now to ensure that AGI goes very well. And I do agree with that, because if we're not going to get this right, other countries could try and rush forward ahead with the technology so that they can, advance their research and design efforts in the military, so they can gain a military advantage. And what happens if there's some kind of security error where those systems go off the rails? I mean, it's truly going to be incredible. And he says, too many smart people underestimate espionage. The capabilities of states and their intelligence agencies are extremely formidable, even in normal, non-all-out AGI race times, and from little that we know publicly, nation states or even less advanced actors have been able to zero-click hack any desired iPhone and a Mac with just a phone number, infiltrate an air-gapped atomic weapons program, modify the Google source code, find dozens of zero-day exploits a year that take on average 7 years to detect, spearfish major tech companies, install keyloggers on an employee device, insert trapdoors in encryption schemes, steal information. I mean, he's basically stating that, look, if little less advanced actors can do this, okay, and this is just the stuff that we know publicly, imagine what, people are probably planning for the race for AGI. Like, imagine what is really going on behind closed doors in order to get the system. Because, guys, AGI is basically a race to it first, and whoever gets the superintelligence first truly does win. Like, I want to make that clear. And he's basically stating here that, look, we need to protect the model weights, especially as we get close to AGI, but this is going to take years of preparation and practice to get right. And of course, we need to protect the algorithmic secrets starting yesterday's. Basically explains here that the model weights are just a large files of numbers on a server, and these can be easily stolen. All it takes is an adversary to match your trillions of dollars and your smartest minds of decades of work just to steal this file. And imagine if the Nazis has gotten an exact duplicate of every atomic bomb made in Los Alamos. Los Alamos was that secret area where people were developing the atomic bomb, and he's basically saying that, look, imagine the stuff from the atomic bomb had gotten to the Nazis. Imagine what the future would look like. That is not a future we do want to create for ourselves, so we need to make sure we keep the model weight secure, or otherwise we're building AGI for any other nation state, even possibly North Korea. He's basically stating that, look, this is a serious problem because all they need to do is automate AI research, build superintelligence, and any lead that the US had would vanish. The power dynamics would shift immediately, and they would launch their own intelligence explosion. What would a future look like if the US is no longer in the lead? And then, of course, this is a problem, because if we find out that they also have the same secrets that we do, this is going to put us existential race, which means that the margin for ensuring that superintelligence is safe is going to completely disappear. And we know that other countries are going to immediately try and race through this gap, where they're going to skip all the safety precautions that any responsible US AGI effort would hope to take. Which is why I said, once people start to think, wait a minute, this is truly the stake of humanity right here, we need to make sure that, okay, we secure everything down. And I'm sure that we're not going to get any more leaks. So now, this is where OpenAI literally yesterday published Securing Research Infrastructure for Advanced AI. We outline our architecture that supports the secure training of frontier models. And basically they say we're sharing some high-level details on the security architecture of our research supercomputers. OpenAI operates some of the largest AI training supercomputers, enabling us to deliver models that are industry-leading in both capabilities and safety while advancing the frontiers of AI. And they're stating that we prioritize security. Basically, through this, they detail certain ways that they have security in terms of course, protecting the model weights. And they're stating that protecting the model weights from exfiltration from the research environment requires a defense in-depth approach that encompasses multiple layers of security. These bespoke controls are tailored to safeguard our research assets against unauthorized access and theft, while ensuring they remain accessible for research and development purposes. Now, I think they did this because OpenAI, I don't think they want the government to come in and say, look, we need to have people in here to make sure that you guys know what you're doing. But I do think that in the future, there's going to be some kind of government intervention, because OpenAI has literally been a company that has been so tumultuous that it is shocking at what has gone on. I mean, the CEO was fired, certain researchers left, certain researchers were fired. Some people are leaving saying that this company's not good for safety. You have some people saying this is happening about AGI, it's going to be next year. I mean, for a company that is literally the most advanced AI company in the world, there is so much drama that has gone on that it doesn't bolster the most trust for the general public in terms of what they're going to be doing with regards to securing the model weight. And in addition, there are currently literal people on Twitter like Jimmy Apples that know when future releases are coming. So how on earth is this even a thing? Because I think there were even some tweets about how certain people were taking pictures of laptops that were in cafes just near OpenAI's research lab, and essentially that's how they were getting the leaked info. So I'm guessing that maybe some OpenAI employees may have just left their laptops open, or maybe someone was taking, screenshots of what was going on their laptops at cafes just outside OpenAI's headquarters. And it's basically stuff like this. Thinking about what's going on here is that they need serious security, because if they are really on the path to AGI, that means they're on the path to superintelligence, which holds a huge implications for the future. And of course, the last part of this is where he talks about superintelligence and aligning this. Reliably controlling AI systems much smarter than we are is an unsolved, repeat, unsolved technical problem. And while it is a solvable problem, things could very easily go off the rails during a rapid intelligence explosion. And managing this will be extremely tense, and failure could be catastrophic. Basically saying that, look, if we make something that is 10 times smarter than us, think about how much smarter than we are from chimps. We're not that much smarter in terms of the IQ, but the fact that we're just a little bit more smarter than them, and we've been able to do so much more, it shows us that, look, you don't need to create something that's a million times smarter than you to realize that it could screw you over and do things that you're not truly going to understand. And of course, this is someone that literally worked on super alignment at OpenAI, so this isn't just a random blog post. And here's where the real problem lies, okay? By the time the decade is out, we're going to have billions of vastly superhuman AI agents running around. And these superhuman AI agents will be capable of extremely complex and creative behavior. We will have no hope of following along. We'll be like first graders trying to supervise with multiple doctorates. In essence, we're going to face the problem of handing off trust. How do we trust that when we tell an AI agent to go and do something, it's going to do that with our best thoughts in mind? This is essentially the alignment problem. We're not going to have any hope of understanding what our billion superintelligences are actually doing, even if they try and explain it to us, because we're not going to have the technical ability to reliably guarantee even basic side constraints for these systems. And he's basically stating that, look, reinforcement learning with human feedback relies on humans being able to understand and supervise AI behavior, which fundamentally won't scale to superhuman system, because this relies on us being able to actually understand and supervise AI behavior, which means we need to actually understand what's going on. And if we don't understand what's going on, then we can't reliably supervise these systems, which means it's not going to scale to superhuman systems. And the craziest thing is that, remember last week, OpenAI literally disbanded its super alignment team. Here is a nice illustration where you can see the little AI giving us a very basic piece of code. And of course, we can easily understand that that looks safe. But here we're like, wait a minute, what is all this stuff? Is this safe? What's going on? It's like, it's very hard to interpret what on earth is going on. In addition, we can see here that some of the problems that may occur are ones that we may not want. So, of course, if we think about, getting a base model to, make money, by default, it may well learn to lie, to commit fraud, to deceive, to hack, to seek power, because in the real world, people actually use this to make money. And of course, we can add the side constraints such as don't lie and don't break the law, but we're not going to be able to understand what they're doing, and therefore we won't be able to penalize the bad behavior. And if we can't add these side constraints, it's not clear what's going to happen. And even maybe they'll learn to behave nicely when humans are looking, and then pursue more nefarious strategies when we aren't watching, which is a real problem. And this is something that actually does occur already. One of the main things that I genuinely think about on a day-to-day basis is this right here, okay? It says, what's more, I expect that within a small number of years, these AI systems will be integrated into many critical systems, including military systems, and failure to do so, okay? This is why it's such a trap, which is why we're on this train barreling down this pathway, which is super risky, is that, think about it like this, okay? Right now we have a thing where
in the future, we're going to have to equip a lot of our technologies with AI systems inside of them, because if we don't, they're just not going to be as effective. And if we don't, we're going to get dominated by our adversaries. But of course, everyone was stating that before AI got this good, we all said we would never connect it to the internet, and now it's connected to the internet and people are not batting an eye. And the problem is that, like, if we get an alignment failure, AI is already in every single infrastructure. So what happens when AI fails and it's in every single piece of technology? So it's pretty insane. And of course, failures on a much larger model could be really, really awful. And here's another graphic which presents, a lot of stuff. This is where we have AGI, reinforcement learning with human feedback. The failures are low stakes. The architecture and algorithms we do understand. The backdrop of the world is pretty normal, but this is where we get to superintelligence. And remember, the transition here is only 2 to 3 years maximum. So once we get to superintelligence, the failures are catastrophic. The architecture is alien and it's designed by the previous generation of super smart AI. It's not going to be designed by humans, okay? And the world is going to be going crazy, okay? There's going to be extraordinary pressures to get this right. And of course, we have no ability to understand if these systems are even aligned, what they're doing, and then we're basically going to be entirely trusting and being reliant on these AI systems. So how on earth are we really even going to get this right? And here's the thing, okay? No matter what we develop, true superintelligence is likely able to get around most any security scheme. And for example, still they buy us a lot more margin for error. And we're going to need any margin we can get. Now, here's one of the scariest things that I think about. And this is something that I saw in only one article covered. Like literally there's only one article covered. There was one Reddit post that I think got removed about this. So I'm not even sure if, anyone's even watching at this point. But basically, if you think about it before, okay, a dictator who wields the power of superintelligence would command concentrated power unlike anything we've ever seen. Think about it, if you manage to control superintelligence, which is of course kind of hard because we won't be able to align it, we could have a situation where there is just complete dictatorship. Millions of AI-controlled robotic law enforcement agents could police their populace, mass surveillance would be hypercharged, dictator-loyal AIs could individually assess every single citizen for dissent with near perfect lie detection sensor rooting out any disloyalty. Essentially, the robotic military and police force could be wholly controlled by a single political leader and are programmed to be perfectly obedient, and there's going to be no risks of coups or rebellions. And his strategy is going to be perfect because he has superintelligence behind them. What does a world look like when we have superintelligence in control by a dictator? There's simply no version of that where you escape, literally. Past dictatorships were not permanent, okay? But superintelligence could eliminate any historical threat to a dictator's rule and lock in their power. And of course, if you believe in freedom and democracy, this is an issue because someone in power, even if they're good, they could still stay in power, but you still need the freedom and democracy to be able to choose. This is why the free world must prevail. So there is so much at stake here that this is why everyone is not taking this into account. So let me know what you thought about situational awareness. I do apologize for making this video so long, but I'm glad I made this video so long because there was still a lot that I looked at that, is not going to be covered in this video. If you do want to watch the podcast, I will leave a link to the video in the description where there is a 4-hour podcast with Leod Aschenbrenner and of course Crash Patel, in which they have an interview that is remarkably insightful. Like, it's really, really good because they just talk about a lot of stuff that you really should know. So if there was anything I missed in this video, let me know what you guys think, because I think this is probably going to be the piece of information that stays with me for the longest time, because I'll be constantly revisiting this document to see if some of these predictions are coming true and where things are lining up.